Hi students, we're going to start by figuring out for tool design the first principle. And the first principle is location, or how do we position the part in space so that whatever process we're trying to do to the part, we can know exactly where it is. Whether that's assembling two parts together, or measuring a part, or machining a part, or just any time that we need to work on a part, we need to know exactly where it is and have it positioned repeatably. So that's what we're going to start with here. So we'll go ahead and get into it by talking about the goals. So what are the tasks that a work holder must accomplish? So it must position the part with respect to the machine or the tool or whatever is going on in a way that's repeatable. It has to be able to withstand the forces of the process. So if the process is something like drilling, we have to be able to have a very high force in the Z direction plus a torque that it can withstand. Instead, if we are milling the part, then it has much higher forces generally in X and Y, and the Z force is lower than the others. If we're doing something like we have a wrench and the person is assembling the part by hand, we have mostly torque on the part. So we will make the work holding so that it can withstand those kinds of forces while maintaining a precise location and not indenting the part. So it has to not warp the part or put big old divots in the part that would cause it to not be in the right location. We have to be able to get to it with whatever tool we're using. So if we need drills to get in there, mills to go around the outside, if we have a measuring tool that needs to go in, or maybe it is a welding head or somebody with a glue gun, maybe it is just being able to position another part in place to do some assembly work. All of these things require that we have the parts with the correct access points. And one of the most challenging things that we'll find in this course is that very often those places that you want the tool to go are also the exact places where you need to locate the part. And so there's always a balance back and forth. And then finally, we need it to be safe for the operator to use. So we need to talk about what are the parts of a work holder. So if we look at just two pieces right here, let's say that we want to hold this top piece to the bottom piece, or we want to position it. Some things that we need some locators so that this thing doesn't slide around. We need to hold it in position or prevent it from moving. Once we've prevented it from moving, we probably also need some clamps to hold it in place so that we're holding it against those locators. And so occasionally you can make the clamps and the locators be the same part of the tool, but that doesn't often work very well. We need a structure, a body. Here it's this lower part, and so that's a big beefy portion of the part, or just made to be strong some way so that it accurately locates this part and withstands those forces of whatever process is happening. And then we need some bracket or something to hold this to the machine that we're using. And so this body has to be held in the machine, whether that's a measurement machine, in which case that's a pretty fine bracket and it doesn't have to withstand much force, or if it's a machining center and we're going to really go to work on this thing, then it has to be big clamps that hold this part down really well. Okay, so some design challenges that we have to endure. Oops, there we go. We need to know which way the forces are acting on the machine, like I said earlier, with sideways forces or Z forces or torque spinning the part. And we need to know what the peak loads are, not just the continuous loads that it might see. We need to know what the stiffness of the workpiece is, because if the workpiece is stiff, then you can hold it at fewer locations. But if the workpiece flexes a lot, then we're going to have to hold it at more locations to be able to keep it from flexing out of the way of the process. We have to know the production volume. If we're making a whole lot of parts, then we can afford to make an automated fixture that will load and unload very quickly, and it can be a dedicated fixture just for that process. But if we're only making 4 of them, then we'd probably use parts that we can assemble together that are reusable for something else afterwards. And it may not matter if it takes a little while to get the part in place and positioned correctly. We need to foolproof it, so that means that we've made it so that the operator can't install it backwards or upside down. And you always have to think about the time that that's going to happen is on late at night when you have a new operator and they don't know what they're doing and they didn't receive enough directions before the supervisor or the previous shift operator went home, and so they're just trying to figure this out, and you can help them by foolproofing it so that the part cannot go in incorrectly, and then you won't come back in the morning to have a whole bunch of parts that were made or measured the wrong way. Part needs to be, or the fixture needs to be very repeatable so that every workpiece you put into it ends up in the same location, and it needs to adapt to any variation or tolerance that is in that workpiece. And so in this class, we're going to look at repeatability a lot and thinking about how do we make it repeatable, but we're also always going to think about, okay, so this positions the part when it's at its maximum material condition. What about its least material condition? Does it still hold it in the right location? And then sometimes we use things that are custom made, and then a lot of the times we try to use purchased components because that really can reduce the cost. Not always. One thing I want to encourage you to do is to utilize this question list that is on page 98 of your book. And so this is just a set of questions that you can ask yourself when designing any locating system, and it can help you to determine if you have done the right thing. Now, these lists for students are often mind-blowing because they are, even within this list, there are items that do not agree with each other. And so you will find in here items like this. Is the parts, or are suspended portions of the workpiece properly supported, and are the locators positioned as far apart as possible? So those two seem like they're different, right? I'm trying to put the locators as far apart as I can, but if I really want to support the part well, I don't want them way out on the ends where the part can bend. I'd want them in a little bit. And so what you have to do is for any particular application, you have to draw from this list, and you can take some of these things and say, okay, that is not the most important thing in this instance. It is, this part is really big, really stiff, so it is more important that I locate it far, far apart than it is to keep it from deflecting because it's just not going to deflect. Or you can decide for any time if that is what is needed. Okay, so that is what we plan to do. So in the next video, we're going to talk about determinism. See you there.